So I want to take a second to go over this week's office visit. Where is it? So we're in the week 8 folder, and here's all the questions. It says, let's see how you're coming along with rational functions. Feel free to use your notes to answer these. So let's make sure we know where the notes are. It's either 4.5 or 4.6. Again, rational functions, that's section 4.5. So I go ahead and click on these right here, and it brings up the notes. So let's go through and talk about these. It says vertical asymptotes are the zeros of the blank. And when we go down here, you can see what we end up doing is they're the zeros of the denominators, right? The vertical asymptotes are the zeros of the denominators. Any graph that is broken up into 3 pieces must represent a function with blank asymptotes. So let's try to find one that's broken up into 3 pieces. When I scroll through these notes, okay, you see this one's broken up into 2 pieces. This one's broken up into 2 pieces. Okay, this one has 3 pieces, right? You see it has this one right here, got this one up here, and this one over here to the right. How many vertical asymptotes does it have? You can see right there, 1 and -1 are the vertical asymptotes. So a graph broken up into 3 pieces represents a function with 2 vertical asymptotes. It says horizontal asymptotes are determined by comparing the blank of the numerator and denominator. Let's go to horizontal asymptotes. They are up here. You look at the degree, right? If p of x and q of x are the same, you look at the leading coefficients. If the one on the top is smaller than the one on the bottom, then y equals 0 will be the horizontal asymptote. If the one on the top is greater, there is no horizontal asymptote. So we find the horizontal by comparing the degrees. What is the procedure for finding the equation of oblique asymptote? We see those are right here. Oblique asymptotes are just slanted asymptotes. You can find them either by using synthetic or long division. So what procedure? Either synthetic or long division. And then x-intercepts are zeros of the numerator. And we talk about that right here. It says the x-intercepts of a rational function are the zeros of the numerator. Finally, it says if the numerator and denominator have a common factor other than a constant, there will be a blank in the graph of the function. Well, the only thing we haven't talked about yet are holes, and if p of x and q of x have a common factor, then the graph will be the reduced one, but there will be a hole in the graph. So if the numerator and the denominator have a common factor, then there will be a hole in the graph.